Okay. But I guess I didn't write them down. All right, so the last couple. Was 39 the last problem? Okay, great. Gives me some space. Here we go. So the population of Jackson is 57,421, growing by 4.78% every 4 years. So from that information, we can immediately get a growth factor. So exponential growth is all about growth factors. That's the key to working your way through these problems. So right off the bat, we can write down a growth factor. Which growth factor can we write down? The 4-year growth factor is 1.0478. Okay, right off the bat. So, how would we get the 8-year growth factor?
Double it.
Times 2. Do you want to double it? Is that right?
No.
Square.
Yes, so we think about in 8 years, you'd end up multiplying by this what? 2 times, right? For the first 4 years, you'd multiply by 1.0478. Then to get the next output, you'd multiply by it again, and that would advance us 8 years. So square, or times itself. So 1.0478 times itself would give us the output 8 years later rather than 4 years later. Okay, so how do we get the percent change? Well, we need to find a decimal approximation for that value. Can someone give me that? You got a calculator? Crank it out. 1 point what? As soon as you get it, tell me. Taking 1.0478 squared.
0.97.
I heard 0.97.
1.0978.
Percent. So what's the percent increase every 8 years? 9.78%. Comes from that 8-year growth factor. All right, the 1-year growth factor. We've got a choice now. So we can go back to the 4-year growth factor. How can we get the 1-year growth factor from the 4-year growth factor? Take it to the, yeah. Square is only the power 2. So raise it to the 1/4. Okay? What's that growth factor? So 1.0478 raised to the 0.25. Raised to the 0.25. Someone else get that? Cool. All right. And what's the percent change for that? 1.17%. Any questions on part A? Does that make sense so far? So part B, similar type of situation. Decreases 18% every 3 years. What's the first thing we want to do? Right away, we can determine which growth factor? 3-hour decay factor, right? The 3-hour decay factor. 3-hour decay factor is 0.18. Is that right? Nope. The decay factor is not the amount of decrease. Rather, it's how much we keep, right? So if you're decreasing by 18%, your decay factor will be the rest of it that we're keeping every 3 hours. Or 1 minus 0.18 equals 0.82. So now, what is that's our 3-hour decay factor. How can we get the 24-hour decay factor from that? He wants to raise it to the 8th. Agree with that? Yeah, because if it's the 3-hour decay factor, how many 3-hour periods are in 24? How many times would we multiply this by this to advance 24 hours? 8 times, right? Because there's 8 3-hour periods in a 24-hour period. All right, let's get that. So what's 0.82 to the 8th?
0.204.
Someone else get that?
Yep.
So what's the percent change every 24-hour period? 20.4%. Is that right? Careful, this is decay. What does the 0.204 mean?
That's what you keep.
That's what you're keeping. Decay factors are the portion that you keep. So if you want the percent decrease, we got to rewrite it as, or decay factor, rewrite that as 1 minus how much we lose. Is it 0.796? So, if 0.204 can be rewritten as 1 minus 0.796, that gives us our percent decrease. 79%, 79.6% decrease every 24 hours. Okay, 1 hour decay factor. So we can go back to the 3-hour decay factor and get it from that. How do we get the 1 hour decay factor? Raise it to the third. What does that equal? 0.5 or 0.4 or something? As soon as you get it, shout it out. What is it? 935. So every hour, are we keeping or losing 93.5%? Keeping 93.5%, therefore, we're losing what we would need to get up to 1, which is 0.065? What percent is that? 6.5%. So if we lose 6.5% every hour, how much do we lose every 3 hours? We lose 18% every 3 hours, and how much do we lose every 24 hours? 79.6% every 24 hours. Questions on number 39? Does it clear it up? Those who voted for this one. If I lost you, ask me. Yes, ma'am. Yeah, so if right, let's see. If it says percent change, then we should put a negative, you're right. If it says how much did it go down or what was the percent decrease, then we're okay to have positive. But if it just says percent change, then we should mathematically say decrease means negative. Like this. See, this says, it doesn't say decreases by negative 18%, it just says decreases by 18%. But then if it asks for the percent change, we should put negative. Other questions? Okay, moving backwards. 37 and 38. Let's see, actually. Is it both of those? Yeah, both. All right, so 37. So the way that I recommended on Monday to handle these with if it has kind of a weird exponent here, is just get that input variable by itself outside the parentheses, and then kind of makes handling it a little easier. So we can rewrite this as 95 times 4, or sorry, so something to just the t. All right, and that way, whatever's inside this parenthesis is the 1 unit growth factor for whatever that unit is. Whatever the unit t is in, then what's in the parentheses is the 1 unit growth factor for t. So what would go inside the parentheses so that we're still equal to what we were given there? He wants 4 to the 1/5. Agree with that? That's what it is. So this is equivalent to saying 4 to the 1/5 and that to the t. So if t is the number of days, then what is 4 to the 1/5? Which growth factor is that? The 1 day. The 1 day growth factor if t is our exponent. Because every time we advance t by 1, we're going to multiply by this. That makes sense, right? So that's our multiplier for 1 day. Every time t increases by 1, we multiply by 1 more of these. All right? So our 1 day growth factor is 4 to the 1/5. So from that, so I would do b first. I would rewrite the function this way, do b first, and then do a. What's the 5 day growth factor then? How can we get it from the 1 day growth factor? Raise it to the 5th, which then equals 4. That's one way to approach it. That's the way I prefer to approach it, because then I never have to memorize anything about, oh, if it's divided by, then it's the whatever, the 5 day or the 1/5 day, or same thing here. I don't have to memorize a rule. I can just always change it into this form, and then I know whatever that unit is, that's my 1 unit growth factor for that unit. Okay, so let's answer these questions now. The initial mass quadruples every 1/5 day. What happens every 1/5 day? What's our growth factor? There's the 1 day growth factor. How would we get the 1/5 day growth factor? We'd take it to the 1/5 again, right? So is this quadrupling? Definitely not. Not quadrupling. All right, initial mass quadruples every 5 days. What's our 5 day growth factor? 4. Does that mean quadrupling? Yeah, multiplying by 4 is quadrupling. That's true. Okay, initial mass increases 50% every 1 day. So here's our 1 day. Let's find the 1 day growth factor. What is it? 1.32. Is that a 50% increase per day? 32% increase. 32% increase. So no good. Questions on 37?
Could we just have plugged in 1 into like t was to get the
In this?
yeah.
Let me think about that. Yeah, sure. So what you're saying is by plugging in t equals 1, you're saying you're going to, what are you multiplying 95 by to get it after 1 day? So that would be the 1, yeah, that works too. The 1 day growth factor, yeah. Other questions on this one? All right, so 38. Same thing. So you could rewrite this as 49 times what to the t? So what would be in the parentheses to the t? He wants 0.97 squared. Agree with that? Yeah, so we could put that whole thing in the parentheses like that, and that would give us the same function as this. And then we know what the 1 month decay factor is. What's the 1 month decay factor then? 0.97 squared. Because every time you advance t by 1, you're going to multiply the output by this 1 time. Let's get that. What is 0.97 squared? 941. Cool. All right. So how would we get, here's the 1 month decay factor. How would we get the 1/2 month decay factor? So we could take the 1 month decay factor and do what to it? Raise it to the 1/2. And I think that's where we get the 0.97. So, true or false? The initial number of buffalo decreases by 3% every 1/2 month. So we look at the 1/2 month decay factor. Is it decreasing 3% every 1/2 month? That's exactly what that means. If we keep 97%, we're decreasing 3%. Yes. Decreases by 3% every 2 months. Well, it can't do both, right? We already said it's decreasing by 3% every half month. It can't do it every 2 months. Decreases by 5.91% every 1 month. Well, our 1 month decay factor was 0.941. Is that corresponds to a 5.91% decrease? Does that give us 5.91? Or in other words, does this equal 1 minus 0.591? It does. True. Question on this one? Anybody have a question? Okay, yeah, so these were the, this is where I showed you last time that growth factors this is the end of class last time. Growth factors. Transferable, easy to get one growth factor from another? Yeah, that's those examples we just did. You basically, if you have one growth factor, you can write the next one down, right? And we just did a bunch of those in those examples. Okay? And then given a certain growth factor, it's easy to find the corresponding percent change, right? But given 1% change, is there an easy, fast way to get another percent change, right? So we showed that last time. There's no one-step calculation to get you from 1% change to another, okay? So if population increases by 60% every 12 years, so let's say this is 12-year percent increase, here is 60%. And we want the annual, the 1 year percent increase. So can we just take the 60% and divide by 12? We can't. So what route are we going to take to get from this 12-year percent increase to 1 year percent increase? First, we're going to do what? We're going to get the so we're going to take this route like this. We're going to get the 12-year growth factor, and from that we're going to get the what? 1 year growth factor, and from that we can get the 1 year percent change. 12-year growth factor. If the 12-year percent increase is 60%, 12-year growth factor is 1.6. If the 12-year growth factor is 1.6, what's the 1 year growth factor? 1.6 to the 1/12th. Find that value. Make sure you get that whole thing as the exponent, 1/12. What's the 1 year percent increase? 4%. Notice, what's 4% times 12? 48%, which is not 60, right? It's not 60%. So you can't just take 4% and multiply it by 12. Why? Because every year, the amount that you have that's going up 4% every year, the amount of increase is increasing. And so the cumulative effect of a higher amount of increase is that over 12 years, the true percent increase is 60%, not 48%. Okay, should I do one more of these? Is there a request? B through E?
Yeah, but
Decay. So either B or E. You want to do B? Okay, so it decreases by 35% every 7 years. Okay, so suppose this is 7 year here. So I'm decreasing 35%. And I'm get the corresponding percent increase for 1 year. What's the route I'm going to take to get from the 7-year percent decrease to the 1-year percent decrease? What's first? 7-year decay factor. 7-year decay factor will be 0, so it'll be 1 minus how much we're going down, which is 0.35, or we're keeping 65%. If we're losing 35%, we keep 0.65 or 65% every 7 years. Next step. We need the 1-year growth factor, which is 0.65 to the 1/7. Tell me what that is. 0.9403. So every 7 years, we're keeping 0.65%. Every 1 year, it means we're keeping 94%. So what's our percent? So rewrite the 0.9403 as 1 minus what? Okay, so 1 minus 0.9403 will be this number that we're decreasing by. Is that 0.5, 0.0507 or something? So what's our percent decrease? Is it negative or percent change? Negative 5.97%. Okay. Questions on this one? Does it make sense? Yeah. Can we do it after class? Let's talk about. Oh, was it? Did I miss that? Was that one on the list?
Yeah.
Any questions on 29? Okay, 35. So this is obviously decay. What is decaying? X value or Y value? What's decaying? Y, output, right? Output is decaying. So we could make a table out of this. Our input, we got 1, 4, 6, and output 367.5. 126.05. 61.766. Okay, so this is what's decaying, the output or the Y value. Okay, the 3-unit decay factor. What does 3-unit refer to? The input or the output? This is change in input, right? We're saying that delta X, or the change in the input, is 3, and the decay factor will be the multiplier that will give us the new output when the input advances by 3. So, do we have convenient information to find the 3-unit decay factor here? Why? From what to what? Yeah, so the input, this could be our advance of 3, or delta X of 3. And so therefore, this multiplier is which decay factor? That's our 3-unit decay factor, because input's advancing 3, and so it's the multiplier that will give us the output 3 units later. So how do we find that multiplier? Yeah, so we can take this number divided by this number. And that will give us the 3-unit decay factor. That will give us the multiplier on this number to give us this number. Okay, what about the 5-unit decay factor? Is it convenient? Can we get that easily? From 1 to 6. 5 units would refer to the input going from 1 to 6, or advancing any 5 units anywhere. So we could take that, we could take the 61.766 and divide by 367.5, and that would be the multiplier that would take us from 367.5 to 61.76. In other words, advance us 5 units of input. You see? So what is, let's do that. What's 61.766 divided by 367.5? Find that number. 0.168. So that is our 5-unit decay factor. Right there. How can we get the 1-unit decay factor? Got some options. How can we use 0.168 to get the 1-unit decay factor? Take to the 1/5. That's right. That would be our 1-unit decay factor. What's that number? 0.7? Exactly? Okay, yeah. All right. How do we get the initial value? Well, the initial value corresponds to what input value? Not 1, but 0. So if we want the initial value, it's the input corresponding to the output corresponding to 0. So we're looking for this value of A. So how can we use growth factors to find this idea of growth factors to find that value of A? Here we've got the 1-unit.
So 0.7 times something equals 367.5.
Yeah, exactly. So we start with that. If we have what we have at 0 and we multiply it by the 1-unit growth factor, it's going to give us the output 1 unit later. Should make sense. This is the same idea. It's just now we have a different unknown. The unknown is the starting value. Multiply it by the growth factor to give you the next output. Right? So I think you get 525 when you solve for A. Question?
Because this chart didn't start from 0, it means that by going from 1 to 4, it's not the 4-unit decay factor.
How many units of input did we advance from 1 to 4? How many units of input do you advance from 1 to 4? 3. So that multiplier would be the 3. Well, what growth factor would you use to multiply by 126 to get 61.766? That would be the 2-unit growth factor because it goes from 4 to 6.
But if it started at 0, then you advance another unit. Right? A difference.
If this was 0 here,
Like if you started at 0 and then they asked them.
if this was 0, then this would be the 4-unit growth factor because it's advancing 4 units from 0 to 4. Yep. Did that help? We good? Okay. So what I want to do is I want you to work on, starting on page 154, while I do finish the workbook checks, starting with number 2 on page 154. Just go in order as is, go slow, think about what you're doing. Don't rush through it, okay? So we're going to start with, for the check, J through L, last name's J through L. Bring your notebook on down. Page 154, start with number 2, just do it as is. Okay, so I'm going to interrupt you and just kind of take a different angle at it. Same idea. So here's a review question. Quantity Q grows 15% every year. What percent does it grow every quarter and month? So, review question. See if you can do it. If quantity Q grows 15% every year, what percent does it grow every quarter and month? This should have been your process. Was that your process? You got to get the, you can't just divide by 4, right? This is what we've been talking about. You can't just divide by 4. You have to get the growth factor annually, and then the quarterly growth factor, and from that, get the percent per quarter. Is that right? Questions on that? So monthly, same thing. You'd start with the 1.15 and do what? So this is, and what number is that right there? What does it mean? Monthly growth factor. And what is it? 1.011? If I remember right? Do I have the numbers right? Okay. So now when it comes to the way that banks handle investments and loans, we break the rules. Okay, what was the rule? The rule was you can't take 15% and divide it by 4 to get the quarterly percent. But to set up investments and loans, that's exactly what banks do. Okay, so APR is the annual percentage rate. So suppose that's 15%, just like we had above. Suppose the APR equals 15%. The quarterly rate is exactly what we said you can't do. This is the way that banks handle it. I don't know the history behind this, but this is what they do. To get the quarterly rate, they take 0.15, the percent increase, and divide by 4. Okay? So this violates everything we've established so far, but it's the way that banks do it. Okay? What is that?
3.75.
Okay, so that's 0.0375. So now from this, what would the quarterly growth factor be? 1.0375. So if this is the quarterly growth factor, find the annual growth factor and the actual percent increase per year. So is this going to be the actual percent increase per year if we do this? It won't be that anymore. So based on this quarterly rate, what is our annual growth factor? Sorry, this is the quarterly growth factor. What's the annual growth factor? How would we find it? Raise it to the 4th. And what do you get? 1586. So what's the percent increase per year? 15.86%. So what just happened? By saying 15% APR with what's called quarterly compounding, you actually don't make a return of 15% on your money. What actual percent do you make at the end of the year? You get this one. Okay, so this is called the APY. And the APY is, Y stands for yield, so it's the annual percentage yield, or the true growth per year. So APR does not tell you actually what percent your money goes up. It depends on how often you, what's called, compound it. This is quarterly compounding. So they start by taking that APR and splitting it up into 4 equal percent across each quarter. So that's our 3.75%. So to find out how much you actually make then, we have to go through our process of find the quarterly growth factor, find the annual growth factor, and get the annual percent from that. So find the APY for 15% compounded monthly. So what would it be if it was 15% compounded monthly? So first we need to find the monthly rate. What would the monthly rate be? 15 over 12, 0.15 over 12. And then how would we get the monthly growth factor? Add 1 to that. So this is our monthly rate. In the parentheses is the monthly growth factor. And then how would you get the annual growth factor? Raise it to the 12th. So find that. That's our annual growth factor for 15% compounded monthly. Find that value. What is it? 16.08%. Or sorry, this is going to be 1.1608, which means 16.08% increase.
What is the whole part?
That's the monthly rate. That's the monthly growth factor. So this is the annual growth factor, the whole thing, which is 1.1608, which means that if you have an APR of 15%, that's truly a 16% increase per year. Okay, so let's leave, and then we'll make an announcement here that we will not have class on Friday. So thanks for staying. But in substitution for that, it'll be an extended kind of reading and workbook posted online, and I'll see you Monday. Okay?
I left the scripts in the mailbox at 11 o'clock.
Hold on a second. Did I ever undo this?